Hello, everyone. Welcome to Mirantis Labs Tech Talks, where we dive into cloud native topics, use cases, tutorials, and many more to educate you all. I'm Avinash Desireddy, Senior Solutions Architect and Developer Advocate here at Mirantis. Joining me today, Kamal Bhaskar, Solutions Architect at Mirantis. He works with our enterprise customers to help containerize applications, build Kubernetes clusters, set up CI/CD process, and many more to uh, for the customers to be successful. Kamal is here to talk about container image security, what exactly it means, and how to remediate the vulnerabilities that are present in these images. Uh, with that, Kamal, can you tell us a little bit more about yourself, please?
Yeah. Hey, thanks, Avinash. So good morning, good afternoon, good evening, everyone in whatever part of the world you are. So hi, this is Kamal Bhaskar. So I'm a solution architect with Mirantis, as Avinash already mentioned, right? So I'm part of Mirantis professional services team. So we deal with our customers and we consult and we basically provide our advice and we help them deploy the Kubernetes clusters, like all the CNCF certified Kubernetes clusters, right? We also help them design the solutions, like the applications, workloads and application solutions, which they want to onboard to the Kubernetes clusters. It could be on the on-prem cloud, or it could be on the public cloud providers. So that's pretty much I do as part of my day-to-day role, right? So as part of this role, I get like exposure on working with like container image security and dealing with the like DevSecOps and GitOps, like all the popular terminologies and the technology we deal with, like in as part of like onboarding the customer applications to Kubernetes and basically containerize them from monolith to microservices architecture. So that's in summary about me. So I'm located in New Delhi, India, and
Thank you, Kamal, for sharing that. And so here's like a quick disclaimer, just to make sure like we are all aligned with the code of conduct. And one other thing is we have the Q&A section activated. Please post any questions that you have in the Q&A section, and we will get through these questions throughout the session. With that, Kamal, please take it away.
yeah, thank you, Avinash. So thanks a lot, everyone, for taking out time from your busy schedule and joining us here to understand on this quite a important topic from containerization perspective. So moving on to the agenda. So basically, we'll be covering an overview of image security, like what image security means and what are like the several attack surfaces we have from containerization perspective and how we should deal with it. What are the best practices around it, right? Then we'll move on to understanding security vulnerabilities. So what are security vulnerabilities? What are like CVEs, as you better know, like, and what they mean to us, right? And why we have such a like quite an organization which basically regulates the vulnerabilities, right, for us, and it builds a database which is basically available to everyone for free to utilize, right, and take out the benefit from it. Then we have scanning for vulnerabilities, like that's the major piece we need to deal with whenever we say DevSecOps, right? So how to scan our container images for any kind of security vulnerabilities and how we should deal with it. And then comes at the end is the remediation part, like how if we have basically find out some vulnerabilities in our container images, how we should remediate them, what should be the process, what are the best practices around that, right? And also we have a short demo how to like get started with one of very popular tools for security vulnerability scanning, and we'll be conducting a short demo for that. So jumping on to the image security, we need to understand the context here, right? So I think we might be, if we are like coming out from a containerization background, or we have already dealt with like some or any of the Kubernetes flavors in the past, right, or any other containerization platform, you might be knowing like there are artifacts called container images which we deal with, right? So basically we build a standardized image or a bundle of all the operating system libraries, and some required packages or softwares over and above these system libraries, right? And our application code. So we bundle it in a standardized and a tested way, and we build it in a well-known format, which we call a container image, right? So we have some tools called like Docker CLI, which we use to basically build our images. We write like Docker files to build these images. Like, we'll not go into like much detail of how we build images, but just to get an idea, right, what images are and how we use it, right? So if you look at this slide on the right side, you can see I've pasted a screenshot. We have a screenshot from Docker Hub for quite a popular app called like MySQL. It's quite a popular database which we are like aware about. So I've taken an official image from their official Docker Hub page, and you can see there are some layers. So like whatever commands we put in our Docker file, right? And we start building our image using the Docker CLI commands, right? So once we build it, every command or every executable command becomes a layer inside that container image, right? So you can also say like container image is a layered bundle of all the standardized or tested container environment which we need for our application, right? So we mostly start with a base image. Like if we want to build a application image which needs to run on some Linux platform, right? So we might want to start with some very basic Linux image. So we normally don't recommend to use like the complete Ubuntu or the complete rel, right, or CentOS images, right? We'll recommend to use like a very minimalistic form of these Linux platforms, right, to avoid any additional libraries which are not required for our application, right? So that's a best practice which is recommended. But there is no like hard uh, requirement around that. Like if you want to use, you can use like the normal Ubuntu or those images as well, but it's not normally a best practice to do that. So we'll understand later in the coming slides why it's not recommended and what are like its drawbacks. So as I said, like container images are standard application delivery formats nowadays for cloud native environments. Like whatever application you're building, you basically build the container image, where you basically bundle all your system libraries required, the software packages and your application code over and above that, and you ship it, start utilizing in that standard format over any of the cloud native environment. It could be Kubernetes, it could be a Docker containerization platform, or any other like OCI containerization platform, right? So moving on to the security threats and attack vectors, right? So as we talk about container images, we talked about like from security perspective, these are like some of the vectors on which there could be some attacks. Like from security perspective, if somebody wants to hack in to your system or to your images, right, and they get a control of your whole platform because of those vulnerabilities or those attack vectors. So we'll be understanding that here, right? So there are several routes on which using which somebody or some intruder can basically attack your containerized deployment. Sorry. So one of them is vulnerable application code. So if you have written something vulnerable from application code perspective, like if you have left some like undesired ports open which are not required for your application, but it is open, your image is not hardened, right? Or if you have left some might be some environment variables or some configuration which contains some sensitive information within your application configuration. So that's one of the way, if somebody gets access to those variables, right, they can utilize it to attack, like basically intrude into your application environment. Badly configured container images, right? If your container images are not basically as per the security best practices, there might be some loopholes. So we'll be going through that in detail in the upcoming slides. Uh, build machine attack. So basically, whenever you build a container image, you use some kind of like your test lab or some kind of your local system to build these images using might be Docker desktop, like some which is a quite a popular solution we use to build application images on our system, on our local laptop or system, right? Or it could be some other jump server in your environment, in your test lab you use to build images using Docker CLI, right? So in those machines, if somebody has got access on those machines, which they are not supposed to, or they've got like root access or like any privileged access on these nodes, they can basically write to your Docker files, which is not desired, right? And you will end up building some you can say corrupted images, right? Which is not good from security perspective. Moving on to the supply chain attacks. So supply chain is basically when you basically pull a base image from a certified container registry like Docker Hub, right? So once you pull it and you start building over and above it, then you push it to your own some private registry within your environment, which is like self-hosted in your organization environment, or it could be the private Docker Hub available on the internet, right? So once you push it there as part of your CI/CD process, right? So during that whole process, and then the deployment which happens after pulling that image from that registry to any of the containerization platforms. So during that process, if somebody hacks in, basically hacks your CI/CD pipeline or the automation scripts you are using to pull the images and push it to your registry and then basically deploy it in your environment, right? If somebody gets access between these pipelines, like the man in the middle attacks, right? They can basically modify your supply chains to create security issues in your environment, right? They will get they can basically hack into your environment, and whatever uh, malware they want to put into these images or supply chain, they can do, right? Then we have badly configured containers. So this is like security on runtime, totally security on runtime. If you have some running containers and you have not hardened them properly, like the image, the ports you are allowing uh, from the container perspective on which they can communicate, right? Other thing is the user. So by default, all the container images which are built, they all the executables we execute while building the image, they are done through a root privileged account, right? So it is recommended to use a non-privileged or non-root account to do all those executables while building the image, so that if somebody might be like modifies that image, sorry, that build uh, container build file, right, or the Docker file, so that might end up in basically deploying a compromised image in your environment, right? Which is not good, again, from your security policy perspective, right? Then we have exposed secrets. It's like if you have some secrets like passwords or some certificates, some application certificates, and which we use for your application endpoints, right? Or some passwords, usernames, right? And you have exposed them in your configuration. So that's another way of like um, getting access to some secret, so sensitive information from your application environment perspective. Then we have container escape vulnerabilities. Like if your container allows launching a terminal or like attaching a terminal somehow to the base host on which the container is hosted, right? So then if somebody has got access to your container, they can escape that container and basically end up logging in into the host on which the container is hosted, and they can do like whatever they want, like from that access. So that's another loop, or like another attack surface or attack vector which is there. So that was about like understanding the threats and the attack vectors. So these are some of the like major best practices, like at least the topmost one, right? If you follow these, you will avoid like most of the attack vectors which we have just discussed, right? So as I said, like initially in our while discussing the container images, right? So we prefer or we recommend as a best practice to use minimal base images. Like we don't recommend to use like the complete OS image. So you generally avoid using base images for like an entire operating system. You should only keep the general system libraries which are required for your application to run, right? Or your project to run, so that it limits the attack surface for the intruder or for the attacker, right? So so there are some well-known images like Alpine, or like one of them which is quite popular, customers use for building like Linux-based images. So there are some quite popular official images available in Docker Hub, which you can utilize, or if you want to build your own custom images, you can do it from scratch. Then we have least privileged users. Like this is a recommendation that I think we discussed briefly while discussing the attack vectors, that if we build an image with the default configuration, right? So it gets built with root privileges. So we recommend using a non-root user or a non-privileged user to basically limit the access from that user while we run all our executables when we build our image, right? So that if anybody gains control inside that image or that image building process, right, they can't do like they will have some restricted access in the image. They can't just do like run everything, like that is the case with the root privileges. So sign and verify images. So we mainly recommend that you make sure that all the images you are pulling or you are creating container with in your environment, you're launching your application workloads, right? They are basically verified and signed so that there is nothing untrusted running on your environment. Like if you're not sure whether that image is the one which you actually launched during that supply chain, if somebody has messed it up with, right? So then you might ending up running a compromised workload in your environment, and in some way you can say your environment is then compromised. So then we move to scan and fix vulnerabilities. So that's the major piece, right? Which is a continuous process. You can't just like do it once and then forget it ever, right? So you have to do it continuously on a regular intervals of time. So normally for every organization, we have a security policy defined, right? So if you follow that, or if you want to build your own security policy for your containerized environment, so we recommend that you scan your images or your environment for all the vulnerabilities, security vulnerabilities, any backdoors or any security misconfigurations, right? And you keep on basically fixing those vulnerabilities if you find any. So we'll be going through in a bit like how we scan and how we fix these vulnerabilities in the upcoming slides. So moving on to the security vulnerabilities, what are these and what we understand by them, right? So as we said, right, security vulnerabilities is kind of a flaw or a weakness, you can say, present in your software, right? So in whatever container image or the piece of software you have built, there might be some glitches or flaws present in that image or in that piece of software, right? Which will allow the intruders or the attackers to gain access to these images, and they will end up basically getting the access to your environment, and then they can then exploit that opportunity, right? So you can say in a summary, you can say security vulnerability is kind of a flaw or weakness in a software or in your container image. So there is a more standardized term which we use for these vulnerabilities called CVE, like common vulnerabilities and exposures. So basically we have an organization, in short they call it Mitre Corporation, right? So they are basically responsible for maintaining a database, and they get funded from like Cybersecurity and Infrastructure Security Agency, which is part of US Department of Homeland Security. So they are maintaining a CVE database with all these CVEs, like all the security flaws which have been found out or which have been discovered till date, right? And that database is available publicly over internet, so anybody can download and utilize it, or if they want to search it like for any vulnerabilities which are there for all the like major or like well-known piece of softwares or packages, right? So that is available over internet, anybody can utilize it. So once we deal with this with the scanning of any of our images or any piece of software, right? So then basically we are dealing with accessing that database and basically checking all our complete environment or the images or those softwares against those CV database. And if we find any of those vulnerabilities present in that particular version of software or database, then we can basically say, okay, uh, we have these flaws present in our environment and we need to work to basically fix it to make our environment more secure. So just for your reference, I have just kept a link to the CV database, which is available. You can download it or you can search it by going to cv.mitre.org. So moving ahead, how do we basically what we mean by scanning and how can we do it? So there are basically many tools. If you go to the CNCF landscape, uh, basically I've kept that link for your reference, right? If you go there, right, and you can see there are many tools available which you can use to scan the artifacts with respect to security vulnerabilities against the CV database available, right? But the most popular one you can say, or which is quite extensively used in the industry. So we have chosen that for basically going into the detail of scanning there, right? For scanning the container images, which is Trivy. So this is a open source tool which is available for even you can download the source code. If you want to customize it, you can do, or if you want to contribute to the community, you can always do that, right? But also you can utilize it for free, right? That's the beauty of open source, right? So it is maintained by an organization called Acure Security, but it's totally open source, right? And anybody from the community can contribute, right? So Trivy is basically, it's a simple and comprehensive tool to basically scan the vulnerabilities and any misconfigurations present in any of the container images. Also, it scans some other artifacts also in addition to the container images. So if you go to the security issues, so it detects three types of security issues. Like one is the vulnerabilities in the OS packages or any of your language specific packages. It detects any of the misconfigurations or any of the secrets which might be exposed in your environment, right? Which should not be done, right? In a plain text format. So these three kind of issues it detects, and it detects these types of issues in three different kind of artifacts mainly. So one is container images, which we are discussing as part of this session. Another one is file system. So it can scan your local file system for any of the misconfigurations or any of the secrets which are present or any of the OS packages which might be vulnerable, right? And it can scan some Git repositories for all these security issues. So if you have a application code which is there available on the Git repo, you can just directly scan that Git repo, and it will basically it means basically that you are scanning your complete source code, your application configurations against these for these security issues. And it basically once you do that scan, it generates a report. There are multiple formats available. We'll be going into that detail once we start doing the demo. So the major ones are one is the tabular format, which is the default. You get a report then and there on the terminal where you're running the CLI commands, right? Or there are some templates available which you can utilize to generate reports in JSON format or HTML format, or there are some serif format which is quite popular with the development folks. So there are these formats options available which you can utilize to generate reports in these formats, whatever is required for your environment. So we'll go into these details once we start working on the demo. So scanning an image. So basically, Trivy is designed in a way so that it can be utilized in the CI process. It can be burnt into that process when you are building your CI pipeline, and you can use it in a very simple way by just calling the Trivy CLI and basically to scan your images and taking decisions against the findings. So another positive point is you don't have to install any kind of Docker CLI or any OCI client to basically download the images. This part is handled within the Trivy code. So it just pulls the image and then scans it and then basically builds a report against that scan, right? So in your CI process, the recommended way is that before pushing any kind of image to a container registry or deploying it as part of your CD process, you can scan that image or any other artifact which is relevant to that process before doing these actions, right? So that you end up basically knowing that what you are trying to basically deploying in your environment, is it vulnerable in any way? And if it is, how you should fix it or how you should deal with it. So Trivy is quite a simple CLI tool. Like you can just pull that CLI on a Linux system or on a Mac OS or on Windows, right? On like whatever operating system you are, or even you can run it as a Docker container while scanning the image. So you can just run this kind of CLI like Trivy image and the pipe and the image name with the tag, and it will pull that image, scan that image, and it will generate the report. So there are quite an extensive option set available with this CLI. So we'll be going through that like in a while. So these are some useful references which we have kept for your reference, like the documentation for the latest version of Trivy. Even if you have like it there for some quite older versions as well, if you want to refer in some case. And there is like the source code for the Trivy project on the GitHub. So moving on, this is an example, like just for reference, if you want to, we'll not be going into like much detail, but I'll just be providing you some idea like how you can basically integrate Trivy in your GitLab in a GitLab CI pipeline, right? And from there you might like go and exploring and research on this. But yeah, we'll be just sticking to this one example from a CI pipeline perspective. And in our demo, we'll just be working on like getting started stuff from Trivy perspective, not going into like CI pipeline stuff. So if we look at this example, right, so you can see there are like three major commands or CLIs which we are using from Trivy perspective. So if you understand that, the first one in red, right, which comments build report. So we can see it basically building a report for one of our applications, for one of our demo applications. And if everything goes smooth, right, this command will exit with code 0. So a 0 exit code means the command was successful, right? So if the report has generated, so the next command will basically again scanning and generating a report, but only for vulnerabilities which are of severity high. So one thing is that whenever Trivy scans any kind of image, right, so it basically generates a report of all the vulnerabilities found in that image, and it categorizes it into multiple categories. So the most threatening one are marked as critical, and then we have high, we have medium, and we have low. So in this CLI, basically we are telling Trivy to scan an image, and for all the vulnerabilities which are marked as high, and if we find like any of the vulnerabilities or if this whole report generation is successful, just exit with code 0. So why we are using this option of exit code here is that we can take decisions within our pipeline looking at these exit codes. If you look at the next command, right, fail on severe vulnerabilities. So if we are scanning an image and if we get like any of the critical level vulnerabilities, so we are exiting this command with exit code 1, right? So 1 means like this test got failed, right? So we can take a decision within our pipeline to either fail this CI pipeline or like so that it doesn't push this image to our registry, or we can like take any decisions looking at these exit codes. So this is one way of dealing with the Trivy CLI in a CI pipeline. A quite simple way, but there are like many more. You can go through the documentation and you can get like more references. And if you want to like do it like more on this side, you can always reach out to us like on emails or on chat. Like we can basically provide you like some understanding. But yeah, for now, like in the interest of time, we have just kept it with this example. So moving on, Trivy also allows you to scan like because why we have kept this slide here is that like most of the customers, like the enterprise customers, they like to maintain private registries which are not like publicly available over internet. So just to make you aware that Trivy also can scan images from private registries. So you can so by default, it pulls images from Docker Hub. If you are not mentioning any of the repository or the registry URL or the endpoint in your Trivy CLI command line, right, then it will just pull it up from Docker Hub and scan it. But if you want to do it from private registry, you can also do that. It supports like private Docker Hub or AWS ECR, GCR, like, or any other self-hosted OCI registry. So just for an example, I've kept like some configurations, some quite simple configurations which you can do if you want to basically scan images from a self-hosted registry. So you just need to set up these environment variables in your environment or on that node where you're running the Trivy, right? And then Trivy will basically take care of pulling the images from that registry using these credentials. And if you want to set up like a non-SSL endpoint for any of your registries, you can also do this with this switch, like Trivy non-SSL true and false. Moving on to the remediation part. So remediation is like quite simple because once you run the scan, right, you get a report. So in the report, you'll get the links for all your CVs which are found in your environment or in your container image. And against those links, you can just basically click on those links, or if you want, you can go to the cvmitre.org website and you can just search for these CV IDs which are found in your report, and you can then follow the recommendations from there. Like so the recommendations are quite standard. It's not like you're finding something which is environment specific, though you can take the decisions while considering your environment when you are planning to deploy these fixes in your environment. But the recommendations we have available in the database, they are quite standard from the software package perspective. So the remediation part, I would say, like for every environment, the remediation plan could be different, but the actual technical steps which you will take to fix the CVs will be same, right? So in a way, you can follow the directions from the links for the CV IDs, right? And once you have those directions, you can plan your like maintenance window or like how you want to do it. Like you can either do it using some configuration management tools like Ansible or any other automation tools, right? Or you can do it manually. So it's a decision which you can take and plan the way you want to do it in your environment. But yes, all the technical steps or the fixes, you'll get it from the database.
Before going into the demo, can we answer a couple of questions that are in the chat, please?
Yeah, sure. We can take the questions. So
the first
is it in the chat or you are saying in the
it is in the
Q&A
section. I'm going to read it out. So the first question is, how can a root privileged container user gain control over entire host?
So what we are saying here is that let's suppose you have built an image with a default configuration and you have not kept it restricted to a non-root user, right? And if somebody can access that root, right? So whatever executable you are running, it will be running through root. So once you log into that container, right, you'll be running everything as root, right? Because you have kept your environment to use the root user. So you'll get all the privileges which are available within that container, right? And I think you are worried about like how you can get access to the entire host, right? So there are some vulnerabilities which are there in the container images, which like most of the like well-maintained images or well-maintained communities, they basically fix those vulnerabilities. But if those vulnerabilities are present in your image, right? So then in that case, somebody can basically launch the session, or they can basically access some of the I would say the socket files, right? They can write to the socket files which are available in the host, right? There are like multiple ways of accessing the information which is sensitive for a host. Like they can get access to your process namespace, right? They can delete some process related files and basically panic the underlying host, right? So there are like multiple ways they can ruin or basically exploit the host which is running that container if those vulnerabilities are available within that image, right? So if we are doing these scans regularly and we are dealing with these vulnerabilities and we are fixing it right on regular basis, so I don't think like that can happen. But it's a best practice that you don't run like your workloads or the containers or the container, you don't build your basically the container images using root privileges if that's not a hard requirement, right? Yeah.
Thank you, Kamal. Uh, One more question is how come it is different from Amazon ECR image scanner? So here, uh, Sita, she's referring to how is Trivy different from AWS ECR image scanner?
Okay, so in a way, so any other image scanner tool, like even the AWS ECR scanner or like any other image scanner tool, right? They are basically doing the same stuff, right? As I said, the scanning process and dealing with the CVE database, which is standard, right? And maintained by a standardized organization, right? The process is same. So they are doing the same stuff, and they'll just be running these checks against your images, and they'll be checking your images against these CV database, sorry, the vulnerabilities which are available in CV database, and they'll be generating a report, right? So every other scanner is doing the same stuff, but it's just that like Trivy is a open source tool, right? I think AWS ECR is, I think it's not an open source, but I'm like not quite sure for now because I haven't like quite extensively used this one. But I would say the process is same. You can say that they are doing the same stuff, but it's just that this one is a open source option available.
Yes, thank you, Kamal, for answering that. And just to add on to that, AWS ECR, like it might have like it has like seamless integration with the AWS like image registry,
Right.
but like Trivy is an open source which can be used with like any registry or like it's a, like CLI binary. So the extensive feature set is not compared, but I'm sure like there is documentation out there which does the comparison between these different scanners. Hope that helps. Okay, we have like a few more questions, but before that, we can just get into the demo and we'll get to the rest of the questions at the end.
Okay, just let me know if you can see the terminal now, and I'll increase
Can
the font size. Is it better, or should I do it more?
just a little more, some more. I think it is better now.
Better now? Okay.
Yep.
Okay, so basically I'm running a Ubuntu machine here. So it's Ubuntu version 20.04 we are running, right? So what we'll be doing as part of this demo, we'll be just installing Trivy, and we'll be running some sample scans, right? And we'll be generating some reports, and we'll have a look like how it looks and how we can utilize this tool. So first of all, the installation is like quite simple. You can just follow, might be I'll just, as a comment for your reference, I'll paste the link here. You can just follow this link, right? So for Linux, you can just basically pull the Debian package for Ubuntu, right? So once you've downloaded this, just do a install using B package. So as the installation is done, now we can just check our installation. It's running fine. So this is the version we are running. So if you want to do a scan, might be to an application called WordPress, might be for version 5.9, right? So here we are running a scan on an image WordPress with tag 5.9, which is hosted like on Docker Hub, right? It's just pulling that image and it is running that, right? So by default, as I said, it basically prints the report in a tabular format, right? So might be I need to just give me a moment. This is going out of window. This is just a sample report. We can have a look here, right? So you can see there are some critical vulnerabilities available. So because I've run this scan on like quite an old version, just to show you that how the vulnerabilities come up, right? But it might not be the case that we have all these vulnerabilities available in the latest version of this software, right? So if we go to the top of this one, we can just see a summary of the findings, right? It found out total 598 vulnerabilities, out of which 336 are low, right? There are some medium and there are some high and critical as well, right? So these are the categories which we were talking about earlier, right? And you can see the fields, it is basically showcasing library title, vulnerability, severity, installed version, fixed version, right? The title. So you can, the most important thing is you can see the severity, the vulnerability ID, package, and the main thing is the link, right? From the remediation perspective. So this is the link I was talking about, right? So if you just go to this link, or if you want, if you go to that link I shared earlier, like from the mitre.crg, .org, you can just search this CV ID in the database, and you can basically have all uh, the remediation steps available there. So I'll just quickly show you. Okay, so if I just search this CV ID, I can find out the details here, right? So this is all about some vulnerability with Apache HTTP server version this, right? Which is basically pointing to these libraries or these functions or methods in the Apache, which might lead to some vulnerability in your environment, right? And this is, I think fixed in some later version. You can see the fixed version. So the current version in our image is this one, right? 2.4.53. And if we update to this one, this is already fixed. So the fix for this vulnerability will be if we'll upgrade to the later version, right? So for the most of the vulnerability you'll see there'll be a fix available, but for like if we have found out some vulnerability like quite recently and there is no fix available, you'll see some kind of workaround given on the database, and if it is not there yet, it will be coming up like in quite some time, right? So the thing is, for most of them you will be finding out a fix, but if for quite a few you can't find out a fix, there'll be a workaround. And if there might be like 1 in 1,000,000 chance like you'll not be finding any workaround for that, right? Then there might be some discussions going around in the industry, like the one for like log4j vulnerabilities which happened right quite some time back. So in that kind of scenarios, you'll be finding out some discussions happening, and when the workaround or like some fix or what is being done within the industry to fix these kind of vulnerabilities. So that was a way to basically generate the report in a tabular format. So I'll just quickly show you like how you can do it in a HTML format, and then I think from there we can go ahead with the code Q&A session. Basically, to generate a report in HTML format, we have some templates available in the Trivy. So if you look at this CLI, right? Just to understand, right, we have a format called template, which we use like if you want to do any non-standard format, which is available out of the box from Trivy, right? Then we can do through using templates, which is the case for HTML, right? So templates, so Trivy community has already built a template for HTML. If you want to build a report in HTML format, then you can just use this template, which is available in the default installation. And you can just provide the output report file and the image you want to scan, right? So if I just run this will generate a report in this HTML format or on this HTML file. Look at there, right? So this is the one it generated. So I've already kind of download and opened it just for your reference so that I can show it up quickly. So this is the kind of format it generates the report in, right? So I just did it quite some time back today, so just to show it quickly. So I've already downloaded it. If you open this one, you will see it in a table, but it's in the HTML format, which is quite like easy to look and understand, right? Yeah, so I think that's about the demo. So So we'll be limiting our demo to this much stuff only for now. Yeah, so if we have any more questions, we can take that up. We are just left with, I think, 9 to 10 minutes now, and then we can might be take further questions later offline if something is
Thank
left.
you, Kamal. Sure, thanks, Kamal. Like, let's go through like some questions that we have. So one other question is, can we integrate Trivy in Azure DevOps pipelines?
Trivy, it can be integrated with like most of the CI solutions, right? Because it doesn't have like dependency on the environment, right? If you have the Trivy CLI available on your DevOps host, like on your CI host, right? Then you can just basically call it any, like it doesn't need like any additional environment configuration, right? You just pull it there, put it there, and then you, if you want to do it like with some private registry, you can just set up some environment variables, or if it is the like container registry within Azure, you can set up the environment variables for that private registry, and it will just start pulling the images from there and start scanning it, right? So the major ones from the documentation, if you look at, I think it will be the major ones are like the GitLab CI and the Travis. Just give me yeah, and Circle CI, right? And GitHub Actions, Bitbucket, right? AWS. But for Azure, I think I don't see like any reason why it will not work. Though you might need to do some configuration in your pipeline to basically set that up, but it should work. But from the documentation perspective, if you look at the link I have shared, right, you'll find the documentation for like these options which I've just mentioned: Travis, GitLab, Circle, Bitbucket, and AWS code pipeline. Yeah.
Yes, thanks, Kamal.
Thank you.
Shiva, I also dropped a link in the chat, which just provides integration between like Trivy and Azure DevOps. So essentially, like just to summarize what Kamal mentioned, it's about setting up the Trivy binary and writing the respective Trivy command in your pipeline at the appropriate step. Okay, let's move on to the next question. In your experience, how does Trivy compare to Sneak and useful features in one but not the other?
Sorry, I have not used Synk yet, so I'll not be able to like compare these two. Yeah, so I don't think like I can answer this specifically, but yeah, Trivy, I think the features we have discussed, I think it's quite extensive. I don't know if you have used Snake already, you might be getting the idea like how Trivy stands against that, but I haven't used Snake yet. Yeah.
Okay. Yeah, just to highlight like one of the feature like through Sneak, when I used it is like Sneak has this ability to test it directly by running a command to like test and monitor all these vulnerabilities once you fix it instead of like rerunning the entire report on an image. But I'm sure like definitely there is like a lot of documentation out there where the comparison is extensive in terms of every feature. So the next question is, where do we need to host Trivy to integrate in CI pipelines?
So hosting Trivy, I think it's the CI host basically where you are running your pipeline, right? So basically, the CLI should be accessible on your CI host where we are basically calling it, right? So you have to make that available. So I think in different solutions it might be different. Like in GitHub Actions, it might be you have to push it to GitHub and then you can call it in your GitHub Actions workflow. So this might be like different in different solutions, but yeah, the CLI should be accessible and should be available on the in the environment, right, or on the host where you are running your CI pipeline. I'm not sure if that answers your question, but yeah, it's like kind of like, no, you are not restricting it to any one solution. So that's what I can say for now.
Yep, hope that helps, Shiva. And the next question is, do we have consolidated view of all images in a private registry?
So I think what I'm getting from this question is that you want to do a consolidated report for all the images in a private registry. Like that's what you want to do. So I would say, as I said, sorry, like there are multiple options. for Trivy to scan, one is like GitHub, another one is the file system, right? And the next one is container image, which we just discussed, right, in detail. So if you want to do like scan all the images in a private registry, I don't think there is a way to have a consolidated report unless you do some automation or like some additional work over and above like Trivy CLI and do it, right? But one way is like if you have a GitHub repo, if you can like run scans on multiple GitHub repo for your organization and do it like through some automation or like might be through using Ansible or like any other tools, right? If you scan that and you can basically generate reports, but consolidating like views for all the images or all the different repos in a single report, I think it's not possible for now using Trivy.
All right, hope that helps. Thank you. The next question is, how can we visualize report changes over time?
Okay, so I think for now, the thing is, this is something which is not like part of this tool. You can't just like create a timeline for all your reports, right? It doesn't maintain it unless you use some like additional, like I would say additional infrastructure you need to create above and around this tool, right? So if you can basically store some reports for your last scans, like might be couple of your last scans, and basically compare it. So you can basically generate reports in JSON, as I said, right? So you can do comparisons over time. Basically decide, have you fixed like any of those vulnerabilities which you found out in your last scan, and basically compare the reports and take decisions over that. So there is no like visualization option available, like I mean the timeline visualization option available for now. But yeah, you can basically do it with some additional maintenance or like additional planning within your environment.
Yes, and just to add some additional context to it, for the open source, there is no timeline, but the company behind Trivy is Aqua Security, and they have an extensive like products to help work on these security issues on the host, on the container level, and everything. And I'm sure like this sort of like timeline feature might be available in one of their enterprise uh, stack.
Solutions, yeah, right. So one of them I think I came across is Starboard, just to add to that, right, which provides some additional functionalities or some automation over and above the Trivy, but I think that might come as an enterprise offering. Yeah, thank you.
Thank you. And couple of more questions are like, how much additional build time is added, and are there any best practices to cache the Trivy database and the tool itself?
Okay, you mean additional build time is from the CI perspective, I think, and are there any best practices to cache? Okay, so caching the database, I think once you scan any of the images for the first time, right, Trivy basically pulls the vulnerability database and it basically caches it on that scanning, like the host where you're running the scan, right, and it utilizes it. So by default, I think it syncs the database every 5 minutes. Like if the database is older than the cache database is older than 5 minutes from the scan you're running now, right? So it will again pull it, cache it on the host, and then utilize it. So that caching is, I think, is already is being taken care by Trivy. So it never lets it like let it like by default older than 5 minutes. It basically checks for newer versions whenever you run it. If it finds the cache version is older than 5 minutes, it repulls and then scans the images, right? The build time is added, I would say. I think we just did a demo, right? So you can see like it had like around over 500 vulnerabilities for that sample image, and it just took like couple of seconds to generate the report. So I think that much, I think you can kind of like got an idea how much time you can add it to your build pipeline, right, if you're running a build through your pipeline. So and just like for your application and for your uh, uh, for the container images which are specific to your environment, right, it might be different. I would say you can't just I can't just provide you some standard build time. It would change for every other image, right? Because it depends how much code, how much libraries, how much data is present, or how many layers are there, right, to scan. So you need to test it, and then only you can comment on that. Yeah. I hope that answers your question. Thank you.
Yep. Thank you. Hope that helps, Manish. And one couple of questions. I know we ran out of time, but it's important to answer these questions. Can Trivy export to a compatible SonarQube format?
So there is a format called Serif, which is quite popular in the GitHub code scanning, right? Which is quite popular. I think I'm not sure if you have used that. So I think that can deal with this requirement. So if you can, I think Avinash has already shared a link, might be. I think if not, I can share, right? So if you go to the reports documentation page, can I? Okay, I can answer type, right? I can type the answer. So I'm just pasting a link here. Oh, sorry. I just responded with a link, right? If you go there, right, you'll see a format called Serif. I think that should help you with this requirement, which is available out of the box with Trivy.
Okay, hope that helps. Thank you, Kamal. And one other question is there any plan on any features that can scan running containers for any new vulnerability?
So basically, Trivy is all about security at rest, right? We are just scanning the images, the packages, and everything, right? So there are some community solutions available which basically scan the running containers for security at runtime, right? So one of them is Conftest, and there are some tools to enforce some security policies and everything in your environment. So I think this question is actually out of the scope for this discussion, but yeah, it's quite a very important component of the container security. So we can't just ignore it. But yeah, this is not the solution for this requirement. You might need to check the solutions like Conftest, which is available, Polaris, right? So these are the solutions which will help you to scan the running containers. Yeah, so I can just type in the names if you want. You can just yeah.
Okay, that addresses all the questions. Thank you so much. Thank you, Kamal, for the wonderful session and all the wonderful content that you have put together. And thank you, everyone, for your active participation. And Kamal, if you don't mind, we are all, Team Mirantis is hiring. And if you would love to come join us, please feel free to check out mirantis.com/careers. And going into the next slide, we have some awesome tech talks coming next week. The first one is on next Tuesday, which is on authentication and authorization in Kubernetes. And the next one is getting started with GitHub security, where Scribe Security, one of our partner organization, is going to talk about how do we always think about security in terms of containers and the pipeline, but they are addressing a unique challenge of it's not just within containers. We also should look at the code base layer, and also uh, how to protect our code repositories, etc. So please, so that happens on July 28th on Thursday at 8 a.m. Please do register for these upcoming workshops, and we hope to see you in these upcoming workshops. With that, thank you so much. Thank you, everyone, for joining us today. Thank you so much, Kamal, for the great content. We hope to see you in the next sessions. Have a good rest of your day. Thank you.
And I'll thank you. I want to thank you all. That was a very wonderful audience, quite interactive, quite a good questions we had, right? So yeah, I'll wish you luck and have a good time, good day. Thank you.